All right, well, we are into one of my favorite types of videos because, as you can see, I have the calculator up and I have my little writing document thing. Anyway, today we're graphing rational functions. And now there are many rules that we need to talk about with graphing rational functions. If you only take notes on one thing from the video, be sure to definitely get down these first couple of things because you will need to know the rules for graphing these things. They're very complicated graphs. So first of all, what is a rational function going to look like? Well, let's look at some examples. Here is a rational function. We're going to graph that. Another example down here. Here is a rational function. We're going to graph that. So in previous sections, we had been doing some canceling stuff with them, right? But now we're going to actually graph these things. So in general, a rational function, it's going to look like a polynomial on top, let's call it p of x, and a polynomial on the bottom, let's call it q of x. So just some random polynomial. And if you look down at our first example, that's totally what's going on here. Look, on top, I have some random polynomial, 2x squared. On the bottom, some random polynomial, x squared minus 9. Okay. Now, finding the x-intercepts and the y-intercepts is exactly the same as it is for all of these equations that we've ever done. You know that for a y-intercept, I need the point 0, comma, something. So in order to find a y-intercept, all I have to do is plug in 0 for x. If you plug in 0 for x, then that will give you the y-intercept. Obviously, simplify things, that will give you the y-intercept. How do I find the x-intercepts? Well, the x-intercepts is something, comma, 0. So in other words, you're setting the y is equal to 0, and then you're solving for x. But there is a trick here. And the trick is this. When you have something over something, as long as the top is equal to 0, I can have anything I want on the bottom, 10, -10, -1. The point is 0 divided by anything always divides to 0. So when you're solving for x, you actually only need to solve the top for x. So you're going to set the equation equal to 0, but only the numerator, or only the top of the fraction. And the reason this works is because as long as I have a 0 on the top, it doesn't matter what's on the bottom, I will get 0 as my answer. And we'll see some examples of this. Now, hopefully you were paying attention in class and you know that there are asymptotes, and there are many asymptotes potentially. There are vertical asymptotes, there are horizontal asymptotes, and they obey some rules. So, the vertical asymptotes are going to come from the bottom of the fraction. Because if the bottom of the fraction, if the denominator is equal to 0, we know that that's not allowed. So the vertical asymptotes are going to come from where the denominator is equal to 0. Or I should say, what x makes the denominator equal to 0? What x makes the denominator equal to 0? And again, we're getting a bunch of these rules down first. Just write them down. Put them in an organized fashion in your notebook, and we'll use them later on, so you'll see how it works. Okay, how about the horizontal asymptotes? So we're actually going to deal with 3 different kinds of functions. There are bottom-heavy functions, there are balanced functions, there are top-heavy functions. Here is an example of a balanced function. The reason this is a balanced function is because the degree, remember the degree is the highest exponent, the degree is the same on the top in the numerator and on the bottom in the denominator. So here the degree of my fraction is 2 for both of these. So this is an example of a balanced function because the degree is the same on the top and the bottom. If the degree is the same, then the equation of my horizontal asymptote is going to be y equals the lead coefficient of the top, let's call it a, over the lead coefficient of the bottom, let's call it b. So let's actually take a look at example number 1 because it's a little bit easier when you see an example. Since this is a balanced function, I know that there is a horizontal asymptote at y equals, well, let's look at the lead coefficient. It's 2 over 1. So in other words, 2 over 1 or just 2. That's a horizontal asymptote, okay? So that's how you find for balanced functions. If it's a bottom-heavy function where the degree on the numerator is smaller than the degree in the denominator, so something like y equals x over x squared. See how this is bottom-heavy? Because there's a bigger exponent on the bottom. This asymptote is always just y equals 0, or in other words, the x-axis. All right, what about top-heavy functions? Something like y equals x cubed over x, where the degree is bigger on top. This is too crazy for us. We're not even going to talk about it. Maybe you'll get into it in pre-calc or college math, but for us, it is too crazy. Okay, so let's actually get into solving these now that we know all the principles. I will try to speed up a bit. Let's take a look at this first equation. First of all, we need to find the asymptotes. It's really important to find these first so I know what points to plug in. First of all, I determined that I have a horizontal asymptote through y equals 2 because it's balanced. We already talked about that. So y equals 2. There's going to be an asymptote. So the graph might get really close to it at the ends, but not touch it. How about the vertical asymptotes though? The vertical asymptotes come from where the denominator is equal to 0, because remember, I'm not allowed to have a denominator of equal to 0. So if my denominator is ever equal to 0, then I have an asymptote there, because I'm not allowed to have points on that part of the graph. So let's first factor the denominator here. I'm going to factor the denominator to x minus 3 times x plus 3. And let's look to see where the denominator might be equal to 0. Well, obviously, if we set the bottom equal to 0, we can use the zero product property to see that, hey, from here, if x equals 3, that's going to be not allowed because it'll make the denominator equal to 0. And hey, here, if x is equal to negative 3, that will also make the denominator equal to 0, which is not allowed. So this was my horizontal asymptote. These are my two vertical asymptotes. It's really easy to find them. Just see where the bottom is equal to 0. So let's also sketch these on. I know that they are vertical asymptotes because the graph is not allowed to touch here. And remember, vertical means up and down. It's written with x equals 3 and x equals negative 3. Okay, so now that I have all my asymptotes sketched, I can also think about the x-intercept. Remember, to find the x-intercept, I need to see where is the entire function equal to 0. At what x points is the function equal to 0? But remember, I said a trick is, really, I can just set the top equal to 0. Because as long as the top is equal to 0, then I know I have the whole function equal to 0. And here it's pretty clear, x equals 0 is the x-intercept. So right here. Well, seems like that's also the y-intercept as well. And let's prove it by plugging in x equals 0. Remember, to find the y-intercept, we plug in x equals 0. So everywhere I see an x, I'm going to plug in 0. And obviously on top I have 0. On the bottom I would have negative 9, but doesn't matter because 0 divided by negative 9 is still 0. Look, the y-intercept, same as the x-intercept, it's at the origin. All right, now we need to figure out some other points here. And here are the rule of thumb. Here's the rule of thumb I'm going to give you. I'm going to need at least 3 points, I'll say at least 3 points, sort of on all sides. And I'll put that in quotes because what I mean by on all sides is I'm going to need 3 points over to the left of this vertical asymptote. I'm going to need 3 points in between the two vertical asymptotes, and I'm going to need 3 points over to the right of the vertical asymptote to get my graph. So let's use our calculator's table function because there's a reason we have these. I don't really want to waste time plugging in all these points. So let me just put in quick 2x squared divided by, make sure to use parentheses to signify that everything you're about to type is on the bottom. Okay, so there's my function. Let's just see how it looks because these graphs look cool. Take a look at this. Now we can sort of see in this graph, you sort of see how there's this like split up and down at the vertical asymptotes, and you see how it's kind of getting really close to this y equals 2 line. Let's actually look at the table for some example points. All right, now, like I said, this is way too big. Let's start the table set at 0. Okay, going back to table. I need 3 points to the left of the first vertical asymptote of x equals -3. So let's do -6 up 2.66667 over -5 up 3.125 and over -4 up 4.5. Notice it says error for -3, so that's a good indication that I picked my vertical asymptote correct. And we need to make sure when we draw in this curve, we draw it so that it's getting really close to both asymptotes. See how here I'm getting close to the vertical asymptote, and here I'm getting close to the horizontal asymptote? That is a well-sketched graph. Now I need 2 points, or 3, in the middle. Let's just I'll use the -2, -1.6, and 2, -1.6. And as we can see from the graph, in the middle, it's kind of doing sort of a parabola thing, except not really. Just make sure that you're getting really close to the vertical asymptotes on either side. And finally, I need 3 points to the right of my other vertical asymptote. And if you notice, they are kind of mirrored. It won't always be that way, but they're kind of mirrored from what I had before. So over 4 up 4.57, over 5 up 3.125, over 7 up 2.5, and just sketch in that smooth curve to get close to the asymptotes. Okay, that's a really cool graph. Let's just discuss the end behavior. Remember, I'm only looking what's happening as x goes to infinity to the right, and as x goes to -infinity to the left. Look, what's this getting really close to as I move to the right? Am I going down forever? No, I'm getting really close to that horizontal asymptote, y equals 2. Same thing over here. As I go to the left, I'm also getting close to the horizontal asymptote. So this is a first equation that we've seen that I'm actually getting close to the asymptote going in either direction. Notice how crazy stuff is happening in the middle here, but the end behavior doesn't really take that into account. I'm only seeing what's happening at the ends. Well, I have all these other examples, but it's already a 12.5-minute video. I don't want to make you watch that long of a video, and it's a little bit too long anyway. So just your summary, this stuff. It's really important to have these facts down. These are the facts that you'll need to kind of have memorized for the test. These are how you find all the relevant information. From there, once we've found all these things, we can use our calculator to find some points once we know where the asymptotes and intercepts are. All right, thanks for watching. Maybe we'll get to some of those other examples in class. See yas.